Thanks, Doug. And yeah, please continue to post your questions. Before we talk about what's our journey with Runsafe been so far, just want to give a quick overview of what type of product we are talking about. So the Vertiv IT systems group that I'm working for provides solutions and products to remotely manage your data center, right? Your data center infrastructure and your equipment, right? Some of you might be familiar with our products as our group was formerly known as Avocent, hence the name of Avocent Core Insight for this product. So specifically, advance this here. Specifically, what we are talking about now, though, is the Avocent Core Insight firmware, and that's essentially a firmware package, actually a suite of firmware and tools for service processors, also called BMCs or baseboard management controllers. And I don't know, many of you might be familiar with that concept, but essentially what that is the baseboard management controller is a little chip, an SoC that's usually integrated on the motherboards of servers, but not only servers, but more and more storage and networking, like switch and router devices do the same. And those SoCs have their own network connection, right? They have their own power, so it's a very independent unit, always accessible from external, even out of band, even if the server OS is not booted and so on. And it provides you pretty powerful functions like, powering on, off, reset the server, right? Giving you remote keyboard, video, and mouse access to really control that server as if you were there, and getting information about its health, right? Getting information about the environmental conditions that the server is operating in. And sometimes you can even recover a server that's not in a good state, right? All the way up to some organizations using a BMC to even provision that server all the way from the ground up, from bare metal. Right, so it's a really critical component in your IT infrastructure. So that's really what basically Avocent Core Insight is, a BMC firmware. Now, what's that related to Yocto? Now, our entire build system has been transformed into a Yocto build. That's not always been the case. So historically, we have been dealing with the more traditional makefile approach. That's been working for quite a while, but you quickly realize that you get into limits on how you can customize, how you can maintain your build system, how you can add features or leverage or moving things around and make it more modular, right? So Yocto does a lot of good things for you. And let me just summarize that really quick, even though I realize maybe many of you are familiar with Yocto, but some might still be deciding. So Yocto has a really large community. Right? It's becoming kind of an industry standard for embedded software. So you get a lot of documentation, it's widely used, right? And you get pretty frequent releases, which helps you stay up to date with bug fixes. What's also important is that actually kind of out of the box, Yocto already comes with a lot of ready-to-use hardware platforms. If the one of your choice is not there, chances are that your hardware vendor might even already provide a Yocto board support package for the particular processor that you're using, or you can easily just basically build your own as an additional layer and add it to the build system. Then there is this feature of binary reproducibility, and I think that's pretty important, especially when it comes to like working in large globally distributed teams like we do. Like every team has its own kind of build servers that they want to use. Even individual developers might want to use their own Linux machines to build, right? And so this build system is designed to build everything from scratch, right? Everything from source, including the actual cross-compiler tool chain. So you're pretty much guaranteed that you're getting the same binary output regardless of where and how you're building. Additionally, there is concepts built into Yocto that really ensure that you're using the exact right source that you actually want to build, right? Especially when you're using a lot of open source where there's like many different versions and they're constantly evolving. There's checks and mechanisms that help you really ensure your build is consistent. And last, but not the least at all, the concept of layers. So layers is probably the most powerful concept in Yocto, which allows you to basically group your source code modules together. And then once you have them grouped into those kind of so-called layers, you can easily move things around. You can actually place them anywhere in your build tree, which has historically been a challenge when you use like traditional makefile-based systems where there's a lot of path names to be worried about. But here, once you have grouped certain functional modules into a layer, you can move them not only within the build tree, but you can even leverage them into other build trees, right? If you have different products that reuse some of your components, just migrate that layer to other build trees. You can also just by turning on and off or removing those layers, you can turn on and off features easily for different products that you might be building based on the same source. And last but not least, the very positive side effect of using these layers is that in a multi-vendor scenario, like in this case, we're working with Runsafe, for example, but you might also work with other vendors. You can quite easily exchange pieces or parts of your firmware, right? By just adding layers of code from other teams in your organization or from third parties. Okay. So let's, before we dive deeper into the Runsafe transformations in our firmware, let's take a quick look on how that firmware stack actually looks like. So here's a kind of a conceptual picture. It's by all means not meant to be complete in terms of its content in that firmware, but it visualizes that there's a lot of individual functional modules and components involved. And they're grouped here by color. So there's all these gray modules, which include the Linux kernel, a dbus for creating a data communication grid that easily makes multiple modules fit together. And all of those gray modules are actually what's called the Open VMC. So some of you in the audience might be familiar or have heard about it, or maybe even using it. It's for us, it's basically the base layer, if you want so, or like you could view it as one large open source component that comes already with a lot of functionality in it. And then we are building our IP on top of this, or in some cases we might slightly modify some of the components or replace components by our own versions of it. So for instance, that we are adding, let's say, a security manager and a couple of other modules that we then call this group of modules, we would call them, for instance, foundation. Right? So, and then we're packaging those into a Yocto layer. Right? And similar for other functionality that we are adding. For example, all these blue modules at the upper right, they're building a powerful and very flexible Redfish stack. Including a web UI that also uses Redfish. Now, this itself, this subsystem of functionality itself is built from many modules, but we are grouping them into a Yocto layer, which we call essentials. And then last but not least, there is all the keyboard, video, mouse redirection and virtual media functionality that's more in pink on the right-hand side. Which we call it the advanced layer. And so by grouping that into layers, not only are you able to quickly remove and add those layers into your build, but you can also build a product structure around that. Like we do in our case, where like we can offer an essential or advanced product, depending on the customer's need. Now, how do we apply the Runsafe technology to this now? Well, first of all, why are we, I should mention really, why are we actually applying Runsafe technology? Now, you heard a lot already from Doug about what that technology actually does, but as I mentioned earlier, BMC is a very critical infrastructure ingredient in your data center, and due to all its external interfaces and network interfaces and APIs that are all externally accessible, it's traditionally been a nice target for cyber attacks, right? So no wonder that we really need to apply an additional layer of security to such a firmware, which we do. And we do that in a few very simple steps. So no wonder it actually becomes a layer, right? In our build system, we just create basically a new meta layer. You can also, like Doug showed, you can also just download the meta layer from Runsafe. You might want to massage it according to your needs, but essentially there is these ingredients in that layer. There is the actual LFR package, which is essentially that secret ingredient, the binary code that basically does the actual transformation. And then there is a so-called VB class, which is really it's a Yocto concept where into that class you can package a whole set of flags and settings and configurations. In this case, it would be additional GCC or linker flags, right? That you're packaging into that class. And then with just one additional line, one additional instruction in Yocto, which is the inherit instruction that you're packaging into that layer, you automatically apply this transformation to all of your recipes, pretty much all of your components in the scope of your Yocto build tree. That's just visualized with those arrows, but really it would actually affect all of the modules at once, at least all the ones that use the GCC and the LD. Now, there might be situations where you want to exclude certain of those modules for the one or the other reason. So that's also fairly easily be done using the Yocto build system. You don't have to go into those individual individual modules, like in this case, the KCS module. You don't have to go in there and do any modifications. Instead, you're putting individual exclusion statements in one central place, which is that actual randomize VB class in the Runsafe layer. And it will have its according effect to that module that you want to exclude. And so last but not least, if as a developer, you just want to quickly turn off all the transformations, being it for like the purpose of troubleshooting or debugging,